So this is a quick rundown on how you can get variable rate of fire using a standard brush motor setup. And the key component here is this brushed electronic speed controller. So these are usually used for drones, commonly used for that. You can also use it for RC cars as well, but usually you'll see these on a quad rotor type setup using the cheaper style brush motors. And the reason why these are not so common is most rotors are being driven by the brushless motors. So that's why you see the 2 leads here as opposed to the normal 3 leads for the brushless. So you can see here that this Turnigy version, which is rated for 20 amps, it has a motor braking circuit that can be enabled with this jumper right here. And it also gives you an option for either lithium or nickel-based batteries. So these are the outs, and these are going to go to your positive and negative leads. So we'll take one here, and we'll put that on the positive lead, and we'll have to check for rotation to make sure that that's correct. One on the negative, and again, these are your signal, quote-unquote, wires, although really they're just polarity. So that's going to go there. And then these leads here go to your battery. Positive and negative. And we're going to be using a 2S graphene for this. And just a word of caution, you really want to make sure you get your polarities correct, because if you invert them, or say you connect the battery to the signal wires, what will happen is you will blow the board. So when you take a look at what's on these boards, it's 3 or 4 MOSFETs, and this little bump right here is the capacitor. So this is the component that will blow first, but you can also destroy the MOSFETs, and that will pretty much trash your speed controller. Alright, so we have power, and what we're using right here is a servo controller. So this is just a simple servo motor controller tester, and we're starting at 0 voltage, and you can see that as we amp up the voltage, that gives us the rotation. And this is showing me that we are spinning clockwise when we need to have counterclockwise rotation in order to properly spin the conveyor belt on the feeder mechanism here. So we'll see that we need to reverse the polarities on the motors. See, that's now feeding in the wrong direction. So let's disconnect that. We'll realign the polarities. So this is supposed to be the ground. Once you have that determined when your motor's in there, one of the things that I like to do is mark. You can either do it with just a colored dot. If you notice, there's already a red colored dot on this motor here, but flip it around and suddenly the positive is now the negative and the negative is the positive. So the best thing to do is just put a little red dot. That's your positive, and if you want to be thorough, then you can put a little black dot here in case the red dot gets rubbed off, and now you know for sure that the red dot on the bottom is going to give you the counterclockwise spin, and that is going to give you your proper rotation. Alright, beep, we got good signal, and now we're feeding in the proper direction. Now, this is really just a tester circuit. You can use it a little bit like, it's essentially a potentiometer. And if you pop on inside, you can see what's actually on circuit board. So we will do that here. This little momentary switch here is to give you the different modes. It'll do like a 50% and a pulse mode. So usually when we're doing this, we're just going to leave it on the wiper mode, so 0% to 100%. This is for external power, and you can have up to 3 leads running off of the same tester. And what we're seeing on the back here is this is the controller chip, and the rest of these are all resistors. I'm not seeing any capacitors on here. So these components are super cheap, and again, they're just made for testing circuits, testing components, but you can alternately use it as a controller. The only problem with that is you need to have a switch. This actually acts as the switch, and that means that you can't splice that into your micro switch to toggle it on and off. So if you want to do that, this has to go out, and this signal and power wire needs to plug into your microcontroller. So if there is a way of using these testers to work with a micro switch, I would love to see it. But as far as I know, not. So, continuing on, the advantage of the speed controllers is that they are very small, as you can see. And because they're also made to operate off of high current batteries, they can handle the LiPos, as you've already seen. So again, this is kind of the core component here, and this is small enough to fit in a Strife. So you can pretty much mount this into any flywheel-based blaster. And I think prices on these vary. I've seen them fluctuating wildly. If you buy them directly through Hobby King, I think I paid less than $6 a piece. But these are more sensitive to current fluctuations than the brushless ones, which are also considerably smaller. So for comparison, this is one of the brushless speed controllers, and you can just see the difference in size. There's no capacitor on it, and we got resistors. I'm not sure what this little yellow chip here is. And then what's covered by the label here is the processor that controls the amount of voltage that goes to each of the motors. And as you see on the motor end, this lead here has 3 leads. So when we take a look at our brushless motor, we have 3 leads. So this is for the brushless setup. We'll go like that. And what we're using here are outrunner based, and again, these are for racing quads. Usually when people use these for Nerf blasters, they use the outrunners as flywheels themselves. So if we did something like this, you can see that the diameter is really small, and these would probably not be suitable for Nerf applications. But tiny, they would fit anywhere. If you had some sort of adapter to put the flywheels running here, then you could pretty much mount it into any Nerf blaster at all. And you can see that the mounting points here can be pretty much put onto a flat sheet. Probably want to mount this on metal, although 3D printed part also probably work as well. So that is your difference between your brushed and your brushless setups. In most cases, you're fine sticking with the cheaper motors, and there's not a huge amount of advantage. They might be a little bit quieter, give you a little more control over the pulse modulation. So there's more that you can do with these brushless. And when you see a lot of these brushless motor blaster-based setups, essentially what they're doing is taking the guts and the controls and everything of the quadcopter and sticking it into a plastic shell for the purpose of accelerating darts. So it's an expensive way of doing it, but it does give you pretty good results. So let's take a closer look at these brushed electronic speed controllers. And we can see we've got our 2 battery leads, our 2 signal leads, which go to the motors, the jumpers, and everything is concealed by this heat shrink. You can see that we kind of have a plate here that is probably a heat sink, and this little capsule here looks like a capacitor. But cut the heat shrink tubing off and we can take a closer look inside. And we can tell that, yes, we have a heatsink here. On the back we can see what looks like it's a MOSFET here. This is some sort of signal controller, because these are the leads that go to the control circuit. Now in our simplified circuit, our test circuit, it simply goes to the servo test. Yep, it says server, but servo test. And when we pop off the aluminum heat shield, or I should say heatsink, we have 3 more MOSFETs. Now the component that is probably the most vulnerable, and I haven't actually resurrected one of these before so I can tell you whether it's doable, is the electrolytic capacitor here. And we can see that it is 470 microfarads, 25 volts. You could easily find these online, probably buy them in bulks of 10 or more. Not expensive. So whether or not you can buy more of these to resurrect dead speed controllers, I'm not going to vet for that because I haven't done it personally. But that is essentially your brush speed controller. And we take a look at that compared to your brushless speed controller. What are we not seeing on here that makes it so small? There is no capacitor and there are no MOSFETs. That is what is making the bulk of this. So we've got the 3 leads here, which tells us that it's for a brushless motor, and everything beyond that looks fairly similar. Except the controller here, 3 versus 2. But if you're using brushless, you can see that these are, you can mount these anywhere. However, these are small enough that you can pretty much mount it in any kind of blaster that is using an automatic pusher. Or if you want, you can also mount these to the flywheel motors, and that would give you an adjustable velocity. Or if you want to go completely crazy, you can have a set of speed controllers going to your flywheel motors. You'd need 2. I don't know if it's possible to drive 2 motors off of a single speed controller. Probably. And you could have another speed controller going to your feeder mechanism for adjustable rate of fire. So adjustable velocity, adjustable rate of fire, using these little guys. And again, they can pretty much be mounted in any blaster because they all have enough space for something that is relatively small like that.